Okay, Trade Kids, this is the second half of the notes for section 10.6. We are now, I think, on example 5. And so what I'm going to do is I'm going to go through example 5. We're going to skip example 6. We'll go through example 7, and then I think what I'm going to do is I'm going to get you started on one of the homework problems, so you guys can kind of see how those, are the same or different from these two examples here. So, example 5, we are taking two vectors and putting them together to find what's called a resultant force or a resultant vector. So remember what we did up here where we used tangent to find the direction and all that good stuff, and use sine and cosine to find this is called component form. So finding component form, sine and cosine of that, to find the direction of a vector, you use tangent. So we're going to kind of combine those things together to do what's called the resultant force. So here's what happens. It says an object at the origin is acted upon by two forces. So I think about this as like a tree stump or something, like there's something chained in the ground and they're trying to pull it out, okay? Somebody is pulling this way and somebody is pulling this way at a certain degree of force. And what's going to happen is when that thing pops out of the ground, whatever it is that we're pulling out, it's going to go in this direction in between those two. And the closer it is to each one of these vectors depends upon how hard that they're pulling. So the first vector is pulling at a 20-degree angle at a force of 150 pounds. Okay, so 150 pounds of force. The second vector is a 70-degree angle, and it's pulling with only 100 pounds of force. And you can kind of see how they've reflected that. They've made this vector longer than this one. So what's going to happen here is when this thing finally pops out, it's going to end up pulling out a little bit closer to the 150 than it is to the 100 because that force is pulling harder. So it's pulling it more in that direction than it is in the 100 direction, okay? So if our angles that we're pulling at is 20 and 70, exactly in between 20 and 70 would be like, 45 degrees. Right? It would be exactly in between 20 and 70, but it's going to be probably a little bit less than 45 degrees because the 150 is pulling harder. So it's going to be pulling closer to the 20-degree angle than it is to the 70-degree angle. Okay. If I just utterly confused you, it'll be okay. Okay. So I'm going to draw these two vectors and I'm going to show you kind of how this works. We're going to work on the 20-degree one first, and then we're going to work on the 70-degree vector next, okay? And what we're going to do is, after I label these guys, we have the 20-degree vector here, and it's pulling with a force of 150, and we have a 70-degree vector here, and it's pulling at a force of 100, okay? And what we want to do, the first step, is to write the vectors in component form. Okay, and component form was this guy right here and this guy right here, okay? And that just tells me the x direction and the y direction. X is here, y is here. And if you remember from before, x always goes with the cosine value and y is with the sine value. Because if I look at this as a right triangle, we've got, if we're solving for x here, we've got x and 150 and 20. And x is the adjacent and the hypotenuse, so we're doing cosine. So cosine of 20 equals x over 150, and I just multiply by 150 to the other side. And I gotta get a calculator really quick. Make sure that you are in degrees when you're doing this, okay, because 20 is in degrees. So 150, 150 times cosine of 20 is 140.95, or let's go 141.0. That's the x direction. Okay. In the y direction, it's going to be the same thing except with sine. Okay. So I'm going to swap him out, and I'm going to say sine of 20 degrees equals x over 150. So we multiply the 150 to the other side. 150 sine of 20, and that is 51.3, okay? So the x direction is 141, and then this one is 51.3. And we just write those in component form. So these are the two components that I have for that first vector, okay? This one is 70 degrees, so it's the same way. If we go the x and the y, to find x, we do cosine of 70 equals x over 100, and multiply the 100 to the other side. So 100 cosine of 70, and that is 34.2, okay? The y-coordinate is going to be the same thing, but just with sine because it's opposite hypotenuse. So 100 times sine of 70, and that is 93.96, so 94.0. Let's go. All right, now, what is happening is these two forces are combining together. And so we have them in component form. We've got this component form, this component form. So what we're going to do is we're going to add those two vectors together to get one final component form. And when we add them together, we just add the 141 and the 34.2, which is like 175.2, I think. Okay. And if we add the y coordinates together, that would be 145.3. That's my final component form. Okay. So that's what this vector is going to look like finally. It's going to go in the x direction, 175, and it's going to go in the y direction, 145, okay? So all we need to do is take this guy and we need to put him back into the magnitude and direction of the resultant force, okay? So we need to find magnitude and we need to find direction, okay? So this is what he looks like. Finally, he's going to go this way. And he's going to go 175.2. I'm getting that from here. And he's going to go 145.3 up. And to find the magnitude, remember that magnitude is just this length here. So we just do the Pythagorean theorem. So 175.2 squared plus 145.3 squared, and then the square root of that. That's going to give me my magnitude. So give me a second. 175.2 squared plus 145.3 squared, and the square root of the answer. And that is a magnitude of 227.6 pounds of force. So this one was pulling 150, this one was pulling 100, so it's going to pop out at 227.6 pounds of force is what's going to happen with the magnitude. And the direction is this angle right here, which is the tangent, right? We've done that tangent before. Tangent of theta, opposite over adjacent. So 145.3 divided by 175.2, and that's when we do that inverse tangent. 145.3 divided by 175.2, and that has a direction of 39.7 degrees. So the direction is 39.7 degrees. Okay, and we kind of said that 45 degrees would be exactly in between 70 and 20, right? But we said it's going to be closer to the 20 degrees than it is to the 70 degrees. So on this side of 45, because 150 is pulling harder. So magnitude, direction, all right? So let's go back over here to our steps here. So after we write the vectors in component form, the second thing that we want to do is add the vectors together. Okay, and then the third and final step is to find the magnitude and direction. Okay, so magnitude was the Pythagorean theorem. I didn't spell Pythagorean theorem right. P-Y-T-H theorem. And the direction was just using inverse tangent to find the direction. So those are kind of your three steps that you can use when you're doing that. Okay, all right. Let's go on down to example 7, and I don't like the way that these pictures are drawn, so let's skip those pictures, and I'm just going to do our own pictures here. An airplane is flying at a direction of 50 degrees with an airspeed of 300 miles per hour. If there was no wind, the course of the airplane would be 50 degrees. However, there is a 35 mile per hour wind from the direction of 120. So what's happening to the plane? Don't draw this because I'm going to erase it. But the plane is wanting to go this way, but it's getting like shoved against the wind, right? The wind is going this way. So it's kind of pushing the plane back, and it's actually traveling like this instead. Okay, it's kind of pushing it up and back against it a little ways. So that's kind of what the wind is doing to the plane. All right. So we have two forces, kind of like the two forces up here, And the forces are the plane, the direction of the plane, and then the direction of the wind, okay? So we have to look at plane versus wind and what's happening, all right? So an airplane is flying in the direction of 50 degrees at a speed of 300, okay? So I'm gonna go here, and I'm gonna go 50 degrees, okay? And we label that magnitude, 300. We label the magnitude of that vector with the 300. So 300 is the speed of it going this way, because that's how the plane travels. The plane travels like that, okay? Then the wind is going 35 miles per hour at a direction of 120, and 120 is going to push us in the second quadrant, so it's going like this, and it's going 35 miles per hour at a direction of 120 degrees, okay? So what we need to do is we need to find the component form of this, okay? So, component form. Okay, now I'm going to cheat a little bit, and I'm just going to, this is a good thing to put on your notes, X and Y. We have found before that X and Y are found by doing cosine of the angle and sine of the angle times the magnitude, okay? So it's like magnitude, cosine of theta, magnitude, sine of theta. So like in this case, my magnitude would be 300, and I would be doing 300 cosine of 50. The magnitude of this guy, to find the y coordinate, we would do the magnitude, which is 300, times sine of 50. That's exactly what we did up above to find those components, okay? You can draw out the triangle if you want to and do it opposite over hypotenuse or adjacent over hypotenuse, but this is kind of a little shortcut of how you do that. Okay, so I'm just going to do just that, 300 cosine of 50, and that is 192.8, and we have 300 sine of 50, and that is 229.8, okay? So that's how it's going. That's the direction in the X and the direction in the Y if I would make this into a triangle, okay? Now over here, we do the same thing again. The magnitude is 35, but I do cosine of 120, and I do 35 cosine, or sine of 120, okay? Now that might be a little bit confusing because if you make this into a triangle, the angle is not actually 120. It would actually be like 60 degrees because subtracting from 180, but if you leave it as 120, it will give you the correct sign here. Like if I do cosine of 120, it's going to be a negative number, and that will reflect that it's in the second quadrant. If you just use 60 degrees, it will be the same thing, but it will not give you the negative number. Okay, so go ahead and leave it as 120. When you type it into your calculator, 35 cosine of 120 is a negative 17.5, okay? The sine value should be positive because he's going up, okay? So 35 sine of 120 is 30.3, okay? And that's what he looks like, right? So you can type it in with 60 if you want to, but if you type it in as 60, it will just give you 17.5 and not negative 17.5 to reflect that it's in the second quadrant, right? Now, that was step number 1, write them both in component form. So step number 2, we have to add those two vectors together, okay? So, I'm running out of room here. 192.8, we take him and we add him to negative 17.5, or just minus 17.5, and that is 175.3. Okay, and then we've got, I think that's 229. Yep, 229. 0.8 plus 30.3, and that is 260.1. I'm not going to try to do these in my head. All right, so that was step number 2. We added the vectors together, and now we have to find the magnitude and direction of the resultant force. So these two coordinates right here, they're still both positive coordinates, even though the wind is negative. It's still going to make me go, the plane go this direction. The plane was directed in this direction, but because the wind is going this way, it's going to make me travel more of that pattern, okay? So what's happening is in the X direction, it's going 175.3, And in the y direction, it's going 260.1, and I need to find the magnitude and the direction. Okay, so again, magnitude is that Pythagorean theorem. So I'm going to take 175.3 and square it, and add it to 260.1 and square it, and then take the square root of that. Okay, 175.3 squared plus 260.1. If I'm going too fast, make sure you pause it so that you can have time to do all this stuff. The direction right here is going to be 313.7 miles per hour. So we have the plane set at 300 miles per hour. Is that right? There was no wind. Oh, did I do that right? Because it should be adding to the, or it should be taking away from the speed of the plane. Now, I guess it would be positive. It would be more. It would be 313 because even though the wind is pushing, it's still pushing the plane up and still kind of contributing to its, I guess. Yeah, that should be fine. That should be fine. Because it's pushing the plane up, so it still is kind of making it go faster, I guess, when it's pushing it up in that direction. So 313.7 miles per hour, so it will speed the plane up a little bit. All right, the direction, though, we need to do the inverse tangent to find direction. So inverse, or tangent of theta is opposite over adjacent, and do inverse tangent of that. So 260.1 divided by 175.3. And that is a direction of 56.0 degrees. So there's my magnitude and direction of the result, okay? So lots of steps to go on those, lots of steps to go, okay? Now your homework is just a little bit, actually it's a lot easier than that. Let's go down to your homework assignment, okay? If you need to pause and go back through, watch those notes again. Fill in any blanks that you need, okay? Let's talk about number 7, though. It's really helpful to draw a picture. Really helpful to draw a picture. So here we go. 2 dogs are pulling on the same bone. Let's say the bone is centered here. One dog is pulling west at 50 degrees, or at 50 newtons of force, okay? West, I'm going to say, is this direction, okay? So north, south, east, west. He's pulling west at 50 newtons of force, okay? The other one is pulling south at 30 newtons of force, okay? So if the 2 dogs are pulling on the bone in that direction, let's think about like where that bone is going to end up, okay? The bone is going to end up getting, like, if it snaps out of both of the dogs, you know, hands, or drags the 2 dogs along, the 2 dogs are going to get dragged this way, okay? But it's going to get dragged a little bit closer this direction because it's 50 newtons of force versus 30 newtons. So the one dog is going to drag it further. It's kind of like a tug of war, you know, like the more force is going to pull it in that direction, okay? So we got to figure out where this vector is going to end up, all right? Now, step number 1 is we need to write both of those vectors in component form, okay? So let's talk about the 50 newtons. Okay, this one is really nice because he is going just this direction, right? Just perfectly at 180 degrees that direction, okay? So what that force is going to look like is in the x direction, he's going negative 50, but he's going 0 up and down. That's what this vector looks like, okay? The 30 vector is going down 30, but none in the x direction. So we have 0, negative 30, okay? And so that one was a lot less involved when it comes to finding the component form of each one of those vectors. And that is because they are going strictly left and down. Okay, it would be the same thing if you're going north and east. Okay, those vectors are really nice and easy. Their component form is very easy to see or very easy to figure out. You don't have to do any sine or cosine computations of that. Okay, so we add this, step number 2, we add those 2 vectors together. Okay, which is also very easy. And it is negative 50, comma, negative 30. if I put the x's together and the y's together, negative 50, negative 30. So we can see that the bone is going to drag the dogs along, and it's going to go negative 50 in the x direction, and it's going to go negative 30 in the y direction, and it's going to pop out, and it's going to end up looking like that. And the only thing that we have left to do is to find the magnitude and to find the direction, okay? So the magnitude is the force that is applied on that bone, and it's going 50 this way and 30 this way, okay? Magnitude is just going to be the Pythagorean theorem. So 50 squared plus 30 squared, and the square root of that, and let's see what I come up with. 50 squared plus 30 squared, and the square root of that is 58.3 newtons of force is what's going to be applied to that bone. And the direction that it's going to go, we just said that it's going to be closer to this direction than it is to the 30, right? It's going to be closer to 50 than it is to 30. So that direction, we use that tangent again. Tangent of the angle equals, oh, wait a second. I labeled the 30 in the wrong spot. I did everything else right, but I labeled the 30 in the wrong spot. 30 should go over here. There you go. Tangent is opposite over adjacent, so 30 over 50, okay? Now, 30 over 50 does reduce, so you could just do inverse tangent of 3 over 5 and have to type less into your calculator. So 3 over 5, and that is inverse tangent of 3 over 5, and that is 31.0 degrees, okay? This guy, 31.0 degrees. Now, the direction, 31.0 degrees, if you just leave it as 31 degrees, they're going to think it's in the first quadrant, like over here, like this is 31 degrees. So you have to add that to 180. So 31 plus 180, and it's actually going to be a direction of 211 degrees, okay? Or there's another way of writing direction when you have north, south, east, and west involved, and it's 31 degrees this way, which they will call 31 degrees south of west direction. It's 31 degrees south, or this way, of this direction, 31 degrees south of the west direction. So that is written like 31 degrees south of the west direction. For some reason, they write the west first. So it's west 31 degrees south, which means 31 degrees south of west, okay? That's a lot of stuff, all right? So whichever way you want to write it, I think you're probably used to writing it as 211, but if you want to challenge yourself and write it as that, go for it, okay? So anytime it has like north, south, east, west, you can write it in this way instead, okay? All right, so hopefully that got you a kind of an idea of how 8 and 9 and 10 and 11 and 12 and 13 are all going to come out. So work on those for the rest of the period, and yeah, we'll see what questions you have, I guess, tomorrow.